Hey team, it's Mr. Z, and again we're going to go ahead and look at some of the key skills in order to prepare for our test. Let's go ahead and dive on in. So in these applications, we're going to use the factor theorem to determine the unknown coefficient so that the given linear expression is a factor. So this is an extension. So remember last time we were talking about how x-intercepts. An x-intercept can either be negative or it can be positive. But in both of these cases, whether it's a negative 1, 0, or if it's a positive 1, 0, in all of them, the output, the y value is equal to 0. You also have to understand that you need to plug in what equals 0. So if x plus 3 is a factor, well, I know the output has to be 0. Hence, we are going to substitute x is equal to negative 3 into my function. So let's go ahead and model it. In this first one, I'm going to substitute 0 in for f of x. And I'm going to take the opportunity to replace all x's with 3. Leave some gaps. I'm going to write my a. I go ahead and put negative 3. Voila. Notice how I have one variable. One variable means I can solve it using traditional methods. Let's go, let's go, let's go. I go ahead and evaluate these guys. 3a plus 15. Positive a times negative 3 is negative 3a. So continuing, 0 is going to be equal to negative 27 minus 81 minus 3a plus 15. I'm going to go ahead and figure out, hey, well, negative 27 and negative 81 together, I'm going to go ahead and calculate. It's going to be negative 108 minus 3a plus 15. I'm going to go ahead and combine negative 108 with 15. This is going to lead to 0 being negative 93 minus 3a. I add 3a to both sides, leaving me with negative 93 on the right side. And now I divide by 3, leaving me with negative 31. So I found the a value. And why is this the one that works? Because f of x is 0. And what did I substitute in? For x plus 3, x minus 3. It's going to be very similar for the next one. If it's x minus 4 is a factor, I go ahead and I have to figure out, well, x plus 4. When is x plus 4 equal to 0? Because it needs to be a x-intercept. Well, x is equal to negative 4. Now I'm ready to go ahead and substitute both my 0, because this is I'm looking at it when it's a factor. And then I'm going to go ahead and substitute in to all of my x values. You can see I get in the habit of leaving a gap and filling it in later. Okay, let's evaluate. So negative 4 to the third is going to be negative 4 times negative 4 times negative 4. 16 times 4 is going to be negative 64. A negative 4 times negative 4 is going to be a positive 16. Negative 20 times negative 4 is going to be a positive 80 minus 48. I go ahead and I'm going to go ahead and just do on the right, I see a quick operation. I'm going to do 80 minus 48. So I'm going to do this rewrite, and then I'm going to do 80 minus 40. 80 minus 40 is 40. I need to take 8 more away, so that's going to lead me to 32. Now I'm going to go ahead and combine my negative 64 with my 32, and since they're different operations, it's going to be subtracting. 64 minus 32 is 32. The negative was larger. It's going to stay negative. I get 16a. I'm going to add 32 to both sides, and then divide by 16. getting an a value of 2. So this is how you use factor theorem to find the unknown coefficient. Essentially, we need to set it up so that we replace both the x and the y because you need one variable to be able to solve this equation. So hope this helped. That's it for now.